From sunny Orlando, Florida, I'm Dr. Ron Klatz for the 16th International Congress on Anti-Aging Medicine, Aesthetic Medicine, and New Biomedical Technologies. It's my pleasure, it really is my pleasure to have Dr. Zanya Weiss from Hawaii. Dr. Weiss is the originator, Dr. Weiss is the president and the owner of Perfector and is it Magnum?
An Ion Magnum.
Ion Magnum Corporation. Dr. Weiss is not just a beautiful and intelligent woman. She's also a very competent scientist. You have a PhD in psychology, clinical psychology?
And also in neurophysiology from London.
Oh, from which school in London?
City University, London.
And your research thesis was?
My research thesis was on cellular regeneration. We used the nerve growth factor, and we were trying to regenerate neurons, different neurons.
You had a very interesting presentation. It was very well attended. For our viewers, maybe you can summarize the thesis of your published paper and also your presentation on nanocurrent and electrical stimulation, how this affects cellular aging.
There is a direct relationship of ionic currents and anti-aging, as there's a direct relationship of ionic currents and development. So embryos have been found to drive ionic currents through themselves. And also stem cells use ionic currents to differentiate and to get to the site that they are supposed to go. Without ionic currents, that's brand new research, Johns Hopkins University, March 2008, that right now they're looking at ionic currents in stem cells. And this university has done a lot of research in stem cells and in engineering.
So we're essentially electrical beings without as the ancient masters have suggested, and as acupuncture suggests, and as recent neurophysiology suggests, there's not just the nervous system that carries impulses throughout our body, but there's actually an electrical field throughout our body. Is this where your research is heading?
That's absolutely right. We're bringing back that that wisdom of the Eastern philosophies, and what we find right now via research, and because until now research was not equipped. We did not have the pico oscilloscopes, we did not have nanocurrent, we did not have picoamperes, we did not have the computers with the appropriate boards to motherboards to show these findings. But right now we have all this equipment to be able to look at the mitochondria, to look at the nucleus, and to find that electricity appears to be everywhere. It's at the backbone of DNA. DNA is conductive. Proteins are made via the amino acids that are connected with each other by charges, electrical charges. So ions, electricity, seems to be everywhere. Proteins are the intelligence of the cell. Without ionic currents, without this attraction between the amino acids, proteins cannot conform. Conformation means the shape of the proteins, and it's the shape of the proteins that makes all the difference. It makes the intelligence of the cell.
So your technology, the Ion Perfector, is that the name of the device?
And the Ion Magnum.
And the Ion Magnum. What do these things do on a cellular basis? I mean, these are electrical generators, and they stimulate the body in what manner? How are they different than standard old-fashioned galvanic electrical stimulation?
Well, they're extremely different. First of all, the current is much smaller, so it's more resonant with the body's own biological functions. And the waveform of those devices is a complex waveform. It's not like the waveforms that they had before. There was a computer-made waveform. There was like a robotic voice that was talking to the body. A complex waveform is very much like a language that is guided by syntax, or it's like a huge judge band that has different instruments, and they're all kind of forming a harmonic music together. Now
but clinically, what do you see? What is the patient
method, or a cell recording method, where they could just pick up part of the membrane and they could isolate and measure the ionic currents. And what they found is that the cell has electricity. The membrane is electric.
So you're talking about the membrane of the cell, and if you were to get right down to it, you can actually measure the amount of electricity that's occurring along that membrane.
That's
and
right.
that's what picocurrent is.
Oh, actually, that's picocurrent.
Picocurrent.
They was
or
measured.
Nanocurrent
is 1/1 billionth, and pico is 1/1 trillion.
A trillion.
And this is what our cells indicate. At rest, they're functioning at picoamperes. But as somebody's more active, there is a higher electrical charge that you see.
But this is such a minute amount of electricity.
Extremely minute.
It's almost impossible to even measure. You have to have very advanced technology to do so.
Well, that's exactly why until now we didn't know.
And that's what your device is? Is yours the first technology to apply these minute amount of electricity to cellular rejuvenation?
Not only cellular rejuvenation, actually, I don't know of a university that has a picoamperage system yet. They don't have the motherboard for that. It's too expensive. So yes, our technology is the first technology that will bring picoamperage in the world, before anybody else. And it's the first technology that does that for cosmetic procedures, absolutely, and anti-aging.
Well, I know there's a lot of excitement around your technology and your devices. I see all the doctors milling around,
yes,
and all the people who are excited about it.
Yes.
And the before and afters are quite impressive. So
yes,
from that point of view alone, it's worth additional scrutiny, and it's worth additional attention. And I thank you so much for being with us. For the American Academy of Anti-Aging Medicine, wishing you a long, healthy, happy lifespan, and with nanotechnology and nanocurrent, maybe even a more beautiful lifespan. I'm Dr. Ron Klatz, president of the A4M. Thank you, Dr. Weiss.
Thank you.